All right, so welcome to the Swift deep dive on loops. And loops are a really important construct in programming in general, not just in Swift. So let's say that we have a scenario where you want a robot to, say, drop a coin on every single tile. And you want him to repeat this process so that he covers all of the tiles on the floor. Now, you could write your code pretty much like this, where you just tell it to move one, put coin, move one, put coin. But notice how many parts of our code is being repeated. And while you could probably simplify this by putting move and put coin into its own function, as we learned previously, and then calling that function, but it's still quite repetitive. And what are we? We're programmers, right? And what does Bill Gates say? Well, he'll always choose a lazy person to do a difficult job because we'll find an easy way to do it. So, how can we be lazy? How can we use programming and the computer to do all of these repetitive tasks instead of us having to type it all out? Well, this is where loops really come in handy. And the most common type of loop that you'll see is the for in loop. So let's say that you've got an array of some names. Say these are the name of your contacts or your friends, and you want to be able to print out each of them in order. Because this is an array, so an ordered sequence of elements, we can simply write for, and we create this entirely new constant in here. So this name is a new constant that we've decided to call name. And then the in keyword is followed by the actual sequence. So in this case, it's our array up here. So now when we go ahead and print each of the names with a hello, then what's going to happen is this loop is going to run for as many times as there are elements in our array. So in this case, it's 1, 2, 3, 4. And once this code gets executed, we'll see hello Anna, and then hello Alex, hello Brian, and hello Jack. So it's looping through our array and it's performing some sort of action, in this case, just simply printing out the name and the word hello. And it's doing this many, many times without us having to explicitly write hello name square bracket 0, hello name square bracket 1, etc. So we can do this as long as we have a sequence to work with. Another way is working with a range, right? So we've seen the range operator, and this, as you might remember, is a closed range operator. So this is a range between 1 and 5, including both 1 and 5. So in this case, we've created, again, another constant, which is called number. And this number is going to be set to equal each value in this sequence for every time this loop gets run. So if we decided to print out the number each time the loop is run, then what's going to happen is that this number constant is first going to be equal to 1 the first time the loop runs, and then this entire block gets executed and we should get the words hello 1 printed, and then the next time number runs, it's now equal to the next value in the range, so it'll be 2, and so on and so forth. So we'll get this looping effect running a total of 5 times because our range goes from 1 all the way up to and including 5. Now, if you didn't actually need to use the value of the numbers in the range, then you can simply bypass it by adding just a underscore. So we could turn our code to look something like this because we don't need that number anymore. We just wanted, say, for example, the word hello printed out 5 times. Then we could change our for loop to look something like this. And now it's going to do what we asked, to print the word hello from 1 to 5, so a total of 5 times. And we're basically just getting our loop to run for a specified number of times without using any of the values inside this sequence that we've provided here. Coming back to our original example where we had our little robot, to simplify things, let's say that we only wanted to put it along this one horizontal line, right? Where it's very much move one, put coin, move one, put coin. And this is the code that we would have had to write if we weren't using loops. But by simply using a loop, we can get put coin move 1 to be repeated 5 times. And again, in this case, we're not using any of the values in our sequence here, so we've put an underscore here instead of a name for a constant. So now let's take a loop at this in our playgrounds and see it in action. Here I've got 5 types of sequences. I've got an array of fruits. I've got a dictionary of contacts and their phone numbers. I've got a string. I've got a half open range, which has that less than symbol at the end, and also a close range, which you saw earlier, which just has the 3 dots. So now I can create a for loop. So as soon as I start writing for, you can see that Xcode gives me that code snippet of a for statement. And you can see that we have 3 parts which we need to fill, and the rest are keywords, the for and the in. So for item in items, the easiest one is of course fruit, right? This is the singular of the fruits plural. This is the name that I'm giving a constant, which is going to be assigned to each element inside my fruits array. So my fruit array goes after the in keyword. And now, as for my code, I'm just going to simply print out each fruit. So notice how this is an array of strings, but this is simply just a string. For every single time this for loop runs, this constant fruit will get assigned a value depending on where we are in this sequence. So now if I run this code, you'll see that it prints out each of the items in order. Now, this is how arrays work. They are ordered sequences. But a close relative of the array is something called a set. And a set is simply a more efficient type of collection that allows you to put in many, many items, such as what we've got here, but it does not guarantee the order of those items. So that means that if I now try and print fruit in fruits, you'll see that I won't get the original order that I put it in, like I did with the array, where I'm guaranteed that it's going to execute it in the order that I created the array. Once it turns into a set, it's just going to do it in the most efficient way possible, and it's going to print out all the items in there, and it's going to loop through all of them, but it's not guaranteeing any sort of particular order. So in certain cases, you might value the efficiency more than the order, in which case you would use a set data type, and other times you really care about the order of the elements that went into that sequence, in which case you would use an array instead. The next thing is we've got a dictionary here, right? And we can do exactly the same thing. We can say for person in our contacts, we're going to print the person's key. So notice how dictionaries are composed of key value pairs, right? Each item that goes in there has a key and a value. So if we loop through our contacts, and every time this loop runs, we turn each of these items into a constant called person, and then we print person.key, we're going to get basically all of the names that's in our dictionary. And if we print person.value instead, we're going to instead get all of the values that are inside our contacts. Now, as you saw earlier in the previous lesson, we can do the same with strings. So if we loop through each letter in our word, supercalifragilisticexpialidocious, and we print each of these letters and go ahead and run our code, then you'll see that it actually takes each and every single letter of that string and prints it out individually. So in total, our loop actually ran a total of 34 times because there's 34 characters in this gigantic word. Now, as you saw in the slides earlier, we can use again the for number in say our half open range and print the number. So now if we hit run, you'll see that it prints 1, 2, 3, 4 up to, but not including 5 because of this little less than symbol, which turns it into a half open range. But instead, if we use the closed range operator, which is just the 3 dots, then you'll see it prints 1, 2, 3, 4, including 5. So it runs the loop a total of 5 times in this case, and in this case it runs it a total of 4 times. So if we wanted to simply just get it to run a particular block of code a number of times, then we can replace this constant with an underscore, which is the same as kind of saying like, let underscore equal, I don't know, 1, 2, 5. Right? This is basically exactly the same thing. It just means that we're not going to be using this constant anywhere within our code. So now we can't print number because it doesn't exist anymore, but we can print something else. We can print loop is running. And now when I hit run, you'll see that in the half open range, it runs 4 times. So my block of code inside here is going to run 4 times as well. Now, another related type of loop is something called a while loop. And while loops work where you have a while keyword and then you have something that is tested, a condition, right? And if this condition, say, I don't know, a is greater than 5 or the sky is equal to blue, if that is true, then this entire loop is going to continuously run until this condition becomes false. As you can imagine, this can be dangerous if you expected something to turn false at some point, but it actually never does. Say you expected, I don't know, the user to type a particular letter, A, but they never type the letter A. Well, then in that case, your while loop is going to run until forever, which is called an infinite loop. And if you search for one infinite loop in Maps, what you'll discover is actually Apple's headquarters. So right here. This is how we programmers try to be funny by building large buildings representing concepts in programming. Going back to our playground, let's say that I wanted to create a while loop instead, right? So I start out with the while keyword. And again, Swift has a code snippet for that as well. And then I have to supply a condition. In this case, what I'm going to test is I want my while loop to run for a single second. So I can get hold of the current time right now by creating a variable called now, by setting it equal to date.time interval since 1970. And it's not going to recognize date because I need to import the foundation module in order to tell it about this date object, which is a single point in time. And the time interval since 1970 is going to give me the number of seconds since 0 o'clock on January the 1st, 1970. So this is a standard in Unix time. And what this means is that this now is going to be equal to the number of seconds since January 1st, 1971. I'm going to create a constant called 1 second from now. And this is simply just going to equal to now plus 1 second. Now remember, this now is actually going to be equal to the value of the time when I run this code, when line 13 gets executed. And then immediately I'm going to add 1 second to it, and I'm going to have a value of the number of seconds since 1970 January 1st plus 1 second. And in my while condition, what I'm going to test is I'm going to say if now happens to be less than 1 second from now, so as in 1 second has yet to pass, this is what that condition tests, well then I'm going to go ahead and print waiting. There's one last thing that I have to do, which is inside my while loop, I have to keep updating this now to equal the current exact time. So that means that initially this gets set to a value, which is used to specify 1 second from now. And then I keep updating the clock to the current value of the clock, and it prints waiting ... until now is no longer less than 1 second from now. So if I go ahead and comment out my for loop and then run this, you'll see that it's going to take a little bit of time because it's actually going to run this code quite a few times. In fact, 3,974 times. And it printed out waiting ... that many times. So this is an indication of just how fast these loops can actually run. Now, the reason why I say while loops are notoriously dangerous is because you have to make sure that this condition never ends up being continuously true until the end of time. Say, instead of checking while now is less than 1 second from now, in which case it will actually stop after a second, if I instead checked a condition where it's always going to be true, say 3 is greater than 2, until the end of time, 3 is still going to be greater than 2. Don't do this because your computer will actually crash, but I'm going to run it on my computer just so you can see what happens. So when I hit run, you're going to see that it's going to continuously go many, many times, and it's not really going to stop until the Mac realizes, well, actually, this process has been going on for a long time, and I probably should interrupt it. And in fact, even if you try to stop the playground, it's actually not really gonna stop your code because it's already running in the background. And at some point, Xcode actually just crashes. So while loops can generate these infinite loops, so you have to be really careful when you're working with them and ensure that the condition is clearly one that can turn false at one point. And the reason why you would use a while loop is because you have a certain condition that you know is eventually going to turn from true to false, but you don't know exactly when. So it could be something that is an unknown. Say, I don't know how long it'll take for a particular image to load from the internet. Well, then maybe the while loop is something you could use. But I recommend trying to use the for loop instead of the while loop, at least when you're starting out, when you're unfamiliar with it, because it's a notorious source of bugs and can generate these infinite loops, of which mine is still going on, by the way, even if I try to tell it to stop. So after this lesson, I recommend having a read of the Swift book on control flow, and that's going to include for-in loops as well as while loops that we talked about. So just get a little bit more background on that, and then we'll head back and continue building out our app.